like an easy way to hook up. So now I kind of know what I think I need to do, because we've got these signals here. It looks like I go, channel A goes from A to C, and channel B goes from B to C. So it looks like I hook up C to ground. Okay, so I get my fancy board here, take the ground wire and hook it up somewhere, and I put the black wire in that one. And then I take the other two and put them somewhere else that I feel like. Doesn't really matter, but I'm going to put them somewhere close, because that's what I do. Right? And I run the other two into them. And again, if I don't like which direction it goes, I can swap them and it'll go the other way. Okay. Okay. And I've done my wiring, my complicated wiring. I come back to here, and I have this thing merrily running away, and if I turn it real slow, what happens is my lights go on and off. Isn't that cool?
Well, both on.
So I'm getting signals, and if I turn it real fast, obviously they're harder to detect them, right? But they are both going out and close. I think that's cool. Okay, so I have signals out of my encoder. Isn't that nice?
Yeah.
Now, do I get any easier wiring than that?
What did you do again?
We had to hook up 3 wires.
3 wires.
I had to hook up the C wire to the ground,
Okay.
and then 1 wire to one of the digital channels, and the other wire to the other digital channel.
Okay, got it.
Okay. And Todd, yours will be exactly the same, except the C wire will have to go to power, plus 5. Okay. Okay. That was easy, wasn't it?
Hold on.
I'm done. Now, only one problem. I have to figure out which way we're moving and how far we moved. Okay.
Put a graph in there.
Okay, well, we can put graphs in there.
Or,
We're gonna do that, but
no,
let's
graph,
go see.
but-
I got these pulses back in here, right?
Mhm.
So how am I gonna tell that? What am I gonna tell? Well, I'm gonna look for changes. So I need to be able to look for changes. So how do I know it's changed?
You turn it.
When it's the up and down.
Yeah, so how am I gonna tell that it's changed? I'm gonna have to say that the new state, what it is now, is what? Is different than what it used to be. Right? So, okay, that's a statement there, right? The new is different than the old. First of all, it means I have to have an old and a new to compare. Okay, in order to make that check, right, I have to have an old and a new to compare. So how am I going to do that? Well, I'm going to have to keep track of what it was the last time it went through the loop. Do we have any place we can store a value so we can use it the next time it goes through a loop? Oh, we might have done that before last time. Shift registers. Right, so I think we're gonna need to put this in a shift register, right? So what are we gonna do? We're gonna go, okay, grumble, grumble, grumble. Those darn professors, they do this kind of thing to me. I'm gonna drag this over here to where it's out of the way.
Does it recognize it's on and off when you press it?
No, because I don't have those hooked up.
Oh, okay.
Okay, I don't have those hooked up. So I'm gonna give myself a shift register over here, somewhere over like in here. I'm gonna make myself a perfectly fine shift register. Right, what am I gonna do? I'm gonna take this shift register and hook it up to channel A. Come on. Give me a wire. Oh, you're gonna be stubborn about it. Give me a wire. There you go. Okay, and then I have a prior value here, right? And I can check those, right? So let's see, what am I gonna wanna do? I'm gonna want a comparison. Well, let's see, I got all kinds of comparisons. Not equal. Hey, that's a cool one. Not equal. Okay, so not equal. And so I can go in here is the new one not equal to the old one? Does that make some sense?
Mhm.
Isn't that a nice civilized thing to do? Right, and if it's doing that, what do I want it to do? Well, let's count up something. Now, how am I gonna make a counter? Well, every time I see a transition, I want it to get bigger by 1. So that means I'm gonna have to add 1 to the count, and I'm gonna have a place to put count. Because I'm gonna have to add 1 to the prior value. And ooh, there's a prior value thing in there, so I think that means another shift register. You think we're gonna wind up with a few shift registers? Okay, so I wanna have a count here, and if there's no counts, I'm not gonna do anything with it, but I do wanna count it when I do that, and I think I'm gonna use one of those really cool select things here. Okay? So I'm gonna put one of these really cool select things in here. If it's false, I don't wanna do anything to it, right? I just want it to sit there, but if it sees one of these fancy transitions here, right? What do I want it to do is I want it to add 1 to whatever's in there. Well, let's see, I could get an add 1 and go to my numeric, and there's an add 1 in here. But you know, these guys might actually be smarter than add 1 in there, because you'd have to sort of run 2 wires. And somewhere down in here, right below that, there's something that says increment. And won't increment just
Increments?
add 1? That sounds cool to me. So I'm just gonna take that and run that in like that, and run that over like that. So what's gonna happen is if it's false, nothing happens, and if it's true, I'm gonna increment it by 1. And then I'm gonna get myself a counter over here, some big indicator, numerical indicator that I'm gonna say is count. Okay? And then I'm gonna blow it up and go size 36, and then we'll make this really big. So because I'm gonna get big numbers. Okay? So, and I got a count here, and now I'm just gonna drag this count in here somewhere. Doesn't really matter where I put it on this wire, I'm just gonna display it. Right, what's the count? Okay, just displaying the count. Let me go run this now. Oh, I got a count because of course it went from 0 to 1, and let me move it pretty slow here. Oh, went 2, went 3, every time channel A changes, oh, went 6, I got a whole bunch of counts there. 7, switches will do that sometimes, particularly cheap switches. So it looks like it counts, I'm going clockwise, it looks like it's counting up very happily there. And if I go counterclockwise, it's still counting.
Because it's just counting the changes.
Because it's just counting changes. Okay, as I go back and forth, and what does it do? It just counts. Okay, so I've got the counting thing down, but I still don't know whether I'm going
Even.
Clockwise or counterclockwise?
Odds.
Well,
No, I guess not.
I guess I'm not sure we're gonna do that, because I can go, just transition, right?
Yeah.
If I got one direction, what do? I get 26, 27, I'm going that clockwise here, right? So it's getting both even and odds, right?
Oh.
Now, so I go clockwise, get the other way. Now if I go counterclockwise, now can you guys tell if I'm going clockwise or counterclockwise?
No.
No.
Yes, you can.
Well, yeah, 'cause it switches
Oh,
the other
left
way.
and right.
Because the which line triggers first.
Well,
Which
yeah.
line triggers
Triggers
first?
first.
Because they're out of phase, right? So we
Yeah.
know that somewhere in there, there's an ability to be able to determine this. So how am I gonna actually count? Because what I wanna do is I wanna get where it counts up one way and then it turns around and
Counts down.
counts back down. Right? If you go, turn around, go the other way,
Formula.
right? Then it's a position sensor, right? So if you get back to where you were, then it should read the same value. Right? Wouldn't that be how it was supposed to work if it was an encoder? A position sensor? Okay, so let's think about this a little bit. And the way we're gonna think about it is I'm going to write a truth table, okay?
Oh, truth
And
is-
so I'm gonna make one up here that, let's say it's clockwise, and we're gonna have A and B. Okay? So we're gonna look at the channels in A and B clockwise, and then we're gonna do counterclockwise. Okay? Now, the first one I'm gonna do is let's look at, we're gonna say clockwise is I go this way. Okay, I'm going from left to right. Okay, so I have clockwise, I go from a low to a high. This is low over here, this is high, right? And a low to a high. So A goes from a low to a high. Okay? And A goes from a low to a high right here. B is low. Right? So if I'm going clockwise, B is low, that's one. Then I come over here, and again, A goes from high to low. And so A goes from high to a low, and B is
Hi.
high.
Aye.
Now, if we look at the counterclockwise, and we have A and B, so I'm going over this way down here, going from right to left. If we have A go from low to high, B is
Hi.
high. And over here, we're gonna have A go from, of course, on this one, high to low, and B is going to be low. And if we look at these, of course, we see that we have 4 states, and they're all different, right? Right? There are 4 states, and they're unique, right? I mean, of these 4 bits, we're looking at just A, line A changing, and then what's the state of B? Okay,
Low, high, high, low.
okay, so that's let's see if we can't implement this over here. Okay, and how about we just implement whether it goes from low to high first? Okay, that's probably the easiest one. Okay, so now how do I tell it goes to low to high? Well, this not equal thing is not going to do it, right? Because not equal is gonna be true when either it went from low to high or high to low, right? So what other comparison might I use instead of equal or not equal? How about greater? Right, wouldn't that get me a low to high? If we'd say low is 0 and then high is 1, right? Which is typically the way these are represented mathematically in the computer, right? Low is 0, high is 1. So a transition from low to high would be that the new value is greater than the previous value. So I could pull that out in here. I'm gonna be a bit lazy and do a replace from the comparison palette and just do greater than, okay? And so if that's the case, right, low to high, then, and B is low, I need another condition in there, right? So I need B is, okay, now B is low. Okay, how do I get B is low? Well, because I'm only gonna wanna increment it. I don't wanna increment it if B is high, right? Because what's gonna happen is it's gonna go the wrong way. I only wanna increment it if B is low. So that's gonna be, two things are gonna have to happen for me to make it go positive, right? I have to see a transition and B has to be low, okay? This and this is another logical statement. That's a Boolean statement. That's an and statement, okay? I have to have two things. So I can go over here to Boolean and I can get an AND gate. I happen to really like AND gates, by the way, so we're gonna use a lot of them. So, okay, what we're gonna do is we're gonna come in here and I'll wire this guy up. 'Cause that's what I do, put an AND gate in here. Yeah, stop that, I don't care. Okay, so that's if I have a transition in A from low to B, and I want B to be low. Well, if I just wire B in here, B low is when B is off, right? When it's 0. So in order to get this AND gate true, I have to have both of the input conditions to be true. So what I want to do is I'm going to need it to not only have this transition from low to high, but I need it to not be B. I need to not be B, so I need a not function, an inverter. It's not B, so I'm going to come over here and go, I don't want B. So this is going to be, if B is low here, this is going to make B high, because an inverter flips the sign, right? If it's 0, it makes it positive. Okay? So this is a statement of this little bit of the line here, right? I have the transition, and I know that I have not B and not B, right? So I have the transition from low to high. That's the greater than, right? The new A is greater than the old A, and not B, right? If B is low over here, then this will make it high. 2 highs in here. This will be true, and it's going to go trip this thing here and increment it once. And because it's changing, it's only going to do that once, right? It's just going to flip that once, and then it's going to go work that way. Now, how do I make it? How about this one over here? I've already got the low to high, right? But I need to do the, what if it's high? I want it to go down, right? I'm going to want it, instead of incrementing, I'm going to want it to decrement. So I go positive one way as I crank it up, and when I do a turnaround, and I go negative as I go back down. So I'm going to need I have an incrementer, I'm going to need a decrementer. Okay, well, how am I going to do that? Well, I've already got an incrementer here. I'm just going to do it again, right? So let's just get another one of these. Right, and I'm going to hook it up over here, and then when it goes bad, I'm going to cut that little piece of the wire out, right, and now I'm going to make that go decrementer, and so instead of increment, I'm going to decrement. Well, it sure is nice people make these fancy functions for me. And now when do I want to do that? Well, I want when I have the transition and B is high. Okay? So, well, shoot, it looks like just another AND gate over here. Right. Well, I already got an AND gate there, it looks like. Not quite sure how that wound up over there. Another AND gate, right? And I'm gonna go one from here, from this guy to this guy. Oops, I don't want you. Come on. In the top there, 'cause I'm gonna be fussy about this. And then I wanna know that I have B. Right, I have B. And by the way, if you start getting confused with these, what do you start doing? Well, you type something on here that says right? Okay, so we got a little bit of logic here, right? We've basically implemented the first line of each of these truth tables, right? I've implemented this one. I'm gonna change, if I have the transition and I don't have B, I'm gonna increment it. And if I have the transition from low to high and I do have B, I'm going to decrement it. Right? Transition from low to high, and that's these first two lines right over here on the code, right? Now we can go see if that works. Think it's gonna work?
Yeah.
So we can go hit run here. Oh, that's a good sign. -1. And I go one way, and what I do, it goes to 0, and then it goes to 2. Then it goes to -3, that's strange. -2, -1,